Hi all. Scaling laws in LLMs define how your model size, that means size of your network and number of parameters, compute as well as available data impacts your model performance, right? And it is mostly based on empirical studies rather than first deciding on paper and deciding, okay, this is the scaling law. People have gone through different inferencing and training, and they observed and they come up with these scaling laws, right? So one of the aspect is, if you have bigger model, it is always good if you have lots of data, right? If you have a very small amount of data and your model is big, it leads to overfitting. That means you are again and again training that model with your very small amount of data. It will lead to a lot of bias, right? So model size, good, big model size is better in most of the cases, but your data should also be of that quality, right? Then data, particularly if you have large amount of data, it is always good for deep learning models, but your data distribution is of quality. If you are just having one particular data which is high number in that data set and others are not that much representative, then probably your training will be bad and you have a lot of bias, right? And then compute, right? It is a very compute and energy consuming thing. And if you don't have enough compute, probably, and your model architecture is not good, probably will be having a very compute heavy operations. That is not good, right? So generally it is viewed in two lenses: underfitting and overfitting. That means you have large model but data is small, that leads to underfitting. That means overfitting, right? And you have a very large data but model size is very small, that leads to underfitting. Now what other things need to consider is cost, right? How much you are spending to train a model, then energy, how much compute you are using, and third one is plateau. Sometimes it happens that just because you are increasing the model size, it will not give any additional impact, because it is the perfect size already reached, so you should stop compute there. So these are different things you need to consider when you actually look at how you scale your LLMs, or you can say these are the scaling laws of LLMs.